Caching is a technique used to store frequently accessed data in a temporary storage area, or cache, to improve the performance and scalability of applications. By reducing the need to repeatedly fetch data from a slower data source, caching can significantly enhance the user experience and reduce latency. In the context of Azure solutions, caching can be implemented using various services and strategies to optimize performance and resource utilization. Implementing caching in your Azure solutions offers numerous benefits. It reduces latency by storing data closer to the application, leading to faster data retrieval. Caching also decreases the load on your primary data sources, which can improve their performance and reduce costs. Additionally, caching can enhance the scalability of your application by handling more requests efficiently. Overall, caching contributes to a better user experience and more efficient resource management. There are several types of caching that can be implemented in Azure solutions. These include in-memory caching, distributed caching, and content delivery network (CDN) caching. In-memory caching stores data in the memory of the application server, providing extremely fast access. Distributed caching involves storing data across multiple servers, ensuring high availability and scalability. CDN caching stores static content closer to the end users, reducing latency and improving load times. Azure Cache for Redis is a fully managed in-memory caching service that provides high throughput and low latency. It is based on the popular open-source Redis cache and is ideal for scenarios requiring fast data access and high performance. Azure Cache for Redis supports various data structures such as strings, hashes, lists, and sets, making it versatile for different caching needs. It also offers features like data persistence, geo-replication, and advanced security. To implement Azure Cache for Redis, you need to create a Redis cache instance in the Azure portal. Once created, you can configure the cache settings, such as the pricing tier, virtual network, and access keys. After setting up the cache, you can integrate it into your application by using the Redis client libraries available for various programming languages. This allows your application to interact with the cache, storing and retrieving data as needed. Effective caching requires the use of appropriate caching strategies. Common strategies include cache aside, read through, write through, and write behind. Cache aside involves the application checking the cache before querying the database. Read through automatically loads data into the cache when it is requested. Write through updates the cache immediately when data is written to the database. Write behind updates the database asynchronously after writing to the cache. Each strategy has its use cases and benefits. Cache expiration policies determine how long data should remain in the cache before being invalidated. Common expiration policies include time to live, TTL, sliding expiration, and absolute expiration. TTL sets a fixed duration for cached data, after which it is removed. Sliding expiration resets the expiration timer each time the data is accessed. Absolute expiration sets a specific time at which the data will be invalidated, regardless of access patterns. Choosing the right expiration policy is crucial for maintaining cache efficiency and data consistency. Cache invalidation is the process of removing outdated or stale data from the cache. Techniques for cache invalidation include manual invalidation, where the application explicitly removes data from the cache, and automated invalidation, which relies on expiration policies. Another technique is cache busting, which involves changing the cache key to force a refresh of the cache data. Effective cache invalidation ensures that the cache remains up to date and consistent with the underlying data source. Monitoring the performance of your cache is essential for ensuring its effectiveness. Azure provides various tools and metrics for monitoring Azure Cache for Redis, such as cache hits, cache misses, and eviction rates. These metrics help you understand how well your cache is performing and identify any potential issues. Additionally, Azure Monitor and Application Insights can be used to set up alerts and gain deeper insights into the cache's behavior, allowing you to optimize its performance. Troubleshooting cache issues involves identifying and resolving problems that affect the cache's performance and reliability. Common issues include high latency, low hit rates, and frequent evictions. To troubleshoot these issues, you can analyze cache metrics, review application logs, and check for configuration errors. Additionally, Azure provides diagnostic tools and support resources to help you resolve cache-related problems. Effective troubleshooting ensures that your cache continues to deliver optimal performance. Optimizing the configuration of your cache involves fine-tuning various settings to achieve the best performance and cost efficiency. Key configuration options include cache size, eviction policies, and data persistence settings. By adjusting these settings based on your application's needs and usage patterns, you can maximize the benefits of caching. Additionally, regularly reviewing and updating your cache configuration ensures that it remains aligned with your application's evolving requirements. Security is a critical aspect of implementing caching in Azure solutions. Azure Cache for Redis provides several security features, such as network isolation, access control, and encryption. Network isolation ensures that only authorized clients can access the cache. Access control allows you to define permissions for different users and applications. Encryption protects data both in transit and at rest. Implementing these security measures helps safeguard your cached data and maintain compliance with security standards. Consider an e-commerce application that experiences high traffic during peak shopping seasons. By implementing Azure Cache for Redis, the application can cache frequently accessed data, such as product details and user sessions, reducing the load on the primary database. This results in faster page load times and a smoother user experience. Additionally, using appropriate caching strategies and expiration policies ensures that the cached data remains up to date and relevant, further enhancing the application's performance and scalability. To make the most of caching in your Azure solutions, follow best practices such as choosing the right caching strategy, setting appropriate expiration policies, and regularly monitoring cache performance. Additionally, ensure that your cache configuration is optimized for your application's needs and that security measures are in place to protect your cached data. By adhering to these best practices, you can maximize the benefits of caching and ensure that your application delivers a high-performance, reliable user experience. Implementing caching in your Azure solutions is a powerful way to enhance performance, scalability, and user experience. By understanding the different types of caching, leveraging Azure Cache for Redis, and following best practices, you can effectively optimize your applications. Remember to monitor and troubleshoot your cache to maintain its efficiency and address any issues promptly. With the right approach, caching can significantly improve the overall performance and reliability of your Azure solutions.